When the first urban power plant was installed by Thomas Edison in New York City in 1882, it served only a small neighborhood and burned a modest amount of fuel. One plant, 58 houses. But as power stations and a delivery grid became a universal concept, the globe's energy requirements became colossal. We began with coal as fuel, moved on to oil, and added natural gas to the mix, all of which have contributed to our problem with CO2. Somewhat cleaner sources of energy were tapped throughout the 20th century, with hydroelectric stations and nuclear plants. And while there is a movement toward clean energy generation from solar and wind, these sources are rolling out too slowly to close the gap between the world's energy supply and the growing demand. As it stands, almost all power generation in the next 20 years or more is going to involve fossil fuels, with coal having a massive resurgence. The world is currently struggling to generate 22 trillion kilowatt hours of electricity per year. Most of it is coming from high-carbon fossil fuels. And by the year 2030, experts predict we will require another 40%. That's 30.8 trillion kilowatt hours per year to power the planet and meet demand. Most of that increase involves rising energy needs in the developing world. Clearly, we need to bridge that gap, and not by relying on high-carbon, non-renewable sources of energy. Creating efficient, clean, and sustainable forms of power production is critical. Is a scientific or transformational technological answer to this crucial global problem within our reach?